whenever we try to write the weight of any object, we name it the mass as m, right? And the weight we write in terms of mass into the gravitational acceleration, right? This is how we write the weight of any object. But wait, what is weight basically? If we talk about, let's say for example, this plane is flying, so what is the weight of this plane or anything like that? Like for example, this train is moving, so what is the weight of this train if we talk about? So basically, if we dig deep, you will be able to understand that the force experienced by the object due to the earth. Okay, so basically we are trying to understand the point, and that is telling us that if this is the earth, right, and if there is an object, right, the force what we experience from here to here, if the radius of the earth is r, right, and one object is over the surface of the earth, for example train or something like that, then this object will definitely experience a force, right? This object will definitely experience a force. For example, this building or this train or this this balloon, they will definitely experience a force due to the gravitational force. So what is that force? From the formula of the Newton's law of gravity, we know that the force is basically is equal to G capital M small m by r square. Now here what will be the r? R will be the radius of the earth, and this is exactly equal to the weight of the object, that is the force experienced by the object due to the earth. So if we simplify this equation, we'll be able to see that the m is going to get cancelled from both sides, and G is equal to Gm by capital R square. And if you look very closely, then you'll be able to understand that this G, this capital M and this R square, they are all constant, right? So G, G, that is universal law of gravity, sorry, universal gravitational constant, it has a value of 6.67 into 10 to the power minus 11, something like that, I guess. Unit, you know that, Newton meter square per kg to the power minus 2, right? Newton meter square per kg to the power minus 2. This is the unit of the G. And the mass of the earth is something I forgot, what is the mass of the earth right now, and radius is approximately 6400 kilometer. Okay, so if you just plug in all these values, then you'll be able to get the value of the G, which is basically near 9.81 meter per second square. Okay, so that is the approximate value. This is not exact value, this is the approximate value of the universal gravitational acceleration, not universal, sorry, this is the Earth's gravitational acceleration. But do you think that, now I'm throwing you one question right now, do you think that this G is constant everywhere? Do you believe that if you are standing here, okay, so if you are standing over here and one person is standing over the surface of the Eiffel Tower, okay, do you believe that these two persons, this person number 1 and person number 2, will experience the same force due to the due to the change in height? Do you believe that? Because I can see that from the formula, the Gm by r square, that is the value of the small g, where capital G is constant, capital M is not also changing for the both of the 1 and 2, both of the cases. But if you look closely, the r, that is basically the distance from the center to the surface of the earth we have taken, but this distance is not actually that, because if we are talking about any object, that object's radius will also come into play when this radius is not very small, right? So now if you are moving over the Eiffel Tower, you went to the top of the Eiffel Tower, now what will happen? The value of the G will increase, decrease, or it will remain the same? Okay, so let's find out.